All right, if you missed the PowerPoint on Google Classroom titled Transformations of Quadratic Functions, this is kind of a little recap. You'll have to still go through the PowerPoint because there are some practice questions on there that will help you. All right, so the first question is asking you if you change, you're given the equation f of x equals x squared, and you change it to g of x equals 2x squared, how does that change your graph? So if you change the equation, how does that change the graph? So we need to go ahead and graph f of x and y1 and g of x and y2 so we can compare the two graphs. Okay, so you should have noticed when you graphed it, the second one was skinnier than the first. So so when we change x squared to 2x squared, we're going to regraph it so you can see it. There's the first one, there's the second one. Your vertex stays the same. This one just gets skinnier than the other one. So the mathematical words that we use to describe that is it vertically stretches, or you'll see the word narrower, and it has the same vertex. Your vertex does not change. So to help you think about the word vertically stretches, if you take a hairband and you stretch it, it gets skinnier. So if I take the hairband and I stretch it vertically, like the name says, it gets skinnier. So that helps you understand that when it's vertically stretching, it gets narrower. So you'll see both of those terms. All right, the next question that we did on the PowerPoint is this one. What happens if I change 2x squared to negative 2x squared? So let's go ahead and put those in. Okay, so looking at the graphs, you should notice something happened. Hopefully you remember the word from middle school. It's like a mirror image or a reflection. So the vertex stayed the same. It didn't get narrower. It just reflected over the x-axis. So looking at how the equations change, it went from 2 to negative 2. So the 2 tells you how wide the parabola is. But remember, like we talked about with vertex form, if it's a positive A, it's opening upwards. If it's a negative A, it's opening downwards. So this one, we will say it's a reflection over the x-axis, because that positive changed to a negative and the A's are exactly the same. And again, it has the same vertex. Okay, the third transformation you might see when you change the A in front of x squared is this one. So I want to give you a second I want you to think about what might happen instead of vertically stretching or reflecting. What do you think happens if I change it from x squared to 1/2 x squared? I want you to make a prediction before we put it in our calculator. Okay, let's graph it and see if your prediction is correct. Okay, what did you notice this time? Hopefully you noticed the second one it graphed, we got wider than the first one. So the mathematical term that you're going to see, instead of wider, you're going to see the word vertically compress or shrink. Or you might see the word wider. But definitely the vertically compress, shrink, and vertically stretch from up here is going to come in a lot in Algebra 2. So let's think about our hair tie again. Here's my hair tie. And if I vertically compress it, it gets wider. Remember, if I vertically stretched it, it got skinnier. Okay, so if you vertically shrink it, it's going to get wider. So that's what happens on that one. All right, the next part makes you think about if I have, so the three transformations we talked about, were reflections, vertically stretch, and vertically compress. So if you're given this equation, y equals 3x squared, I want you to think about an equation that might help you reflect it, make it vertically stretch. Remember the other word for stretches was narrower. And make it vertically compress, which is wider. So I'm going to pause right now. I want you to do the same, and I want you to think about an equation, looking at our examples, that would make it do one at a time. So give me one that makes it reflect, give me one that makes it stretch, and one that makes it wider. Okay, so I put in 3x squared into y1, and I want one that reflects. So looking back at my example, since this was a positive 2 and this was a negative 2, I'm thinking if this is a positive 3, if I change it to a negative 3, oops, it will probably reflect. And I'm going to double check that that happens. And that's exactly what happens. So changing that 3 to a negative 3 will make it reflect. Okay, delete y2. Now I'm thinking about one that makes it narrower. So looking back at my example, this one changed from a 1 to a 2. So with a 1 to a 2, it got to make it stretch or narrower or skinnier. It went from 1 to 2 and got bigger. So I'm thinking if it got narrower, if it goes from 3, it needs to change to at least 4 to make it bigger. So let's try it, or to make it stretch, vertically stretch. So there's 3x squared, and there's 4x squared. It's a little bit skinnier. You might have tried 5. You might have tried 6. So anything bigger than 3 should make it vertically stretch or get skinnier. Okay, so then the opposite, to make it compress or get wider, instead of getting bigger than 3, it should get smaller than 3. So I'm going to try 2x squared. So there's 3x squared and there's 2x squared. It's a little bit wider than that. So I can try 1x squared and see what happens. It got even wider. I could try 1/2. Some of you might use that and got even wider. Okay, but I want you to think about, what if I changed it to negative 1x squared? What's going to happen there? Okay, so you should saw two things get happening. It did reflect, it reflected, and it got wider. So on your notes, we're going to talk about what exactly why it gets wider or narrow and what happens to A. But for now, you should have kind of discovered that. Okay, that's one of the transformations that we talked about in the PowerPoint. All right. The next transformation we talked about is, what if you change the C? Remember, ax squared plus bx plus c, then c is the number by itself. So when we change it from 2 to 5, we're going to talk about what happens. So I'm going to type in x squared plus 2 into y1, x squared plus 5 into y2, and we're going to watch what happens. Okay, so this one's here, this one's here, so the vertex changed. It looks like this one right here is skinnier than the other one because it's inside of it, but if I zoom out, they're the exact, they look like they're pretty much the exact same width. They are the exact same width, but they look like they're pretty much on top of each other because it's zoomed out. So I'm going to go back and push zoom 6 again. So since the A didn't change at all, only the C changed, the width of it is not going to change. So it's going to stay the same width, but it's going to, it moved from 2 up to 3. So we call that a translation or a shift up. And since it's going up, it would be vertical shift. So you might here see all those words. You can see vertical shift up, you'll see vertical translation up. Those are the different ways that you'll see it. But the important thing is that you understand that it moves up. Okay, so the second example was x squared plus 3, and then it changed to x squared minus 1. You can probably already predict what's going to happen there. So instead of x squared plus 3, it's changing to x squared minus 1. Oops, I did something wrong. Oh. Okay, there's x squared plus 3, and then there's x squared minus 1. Again, it looks like the bottom one is bigger than the other one, but if I zoom out, they're the same width, just one is a little bit down from the other. So go back to zoom 6. Since A did not change, they say the same width, your just vertex changes, and it vertically shifted. This time it vertically shifted down. Okay, so then there were some more practice questions that went with that. All right, then the next one that we talked about, other transformation that can happen, is on the next part. So x squared changes to x minus 1 squared, and then we graph. Okay, and you should notice they're the same width because your A, remember, that number in front of x squared or the number from the parentheses stay the same. But I'm going to graph it again. Here's the first one, there's the second one, and you should have saw it shifted to the right one time. So we call that a horizontal shift, and we're going to the right. Okay, so obviously we would probably predict that the next one, instead of going to the right, is going to go to the left. And we remember back to vertex form, we'll get more of that into that with our notes. Remembering vertex form, what happens to the vertex will help you with that. Okay, so here's x squared, and then there's x plus 2 squared, and it shifted to the left this time 2 times. Okay, so there's some more practice questions that go with that on the PowerPoint, and then there'll also be a note page for you for that.